Okay, I'm going to try to get you guys some questions answered. Just for anybody that's absent or first period class, I had a meeting at Horizon Education Association this morning, and so I know you have some questions about this. So I'm going to start right here. I'm assuming you can put your numbers in your calculator. Just remember, list 1, those are your X values, and list 2 is your Y. So when you're using your calculator to make a stat plot, you're just plotting points, okay? So there's 2 parts to this problem. One part is pick 2 points and find the equation of the line through those points. You can push trace and it'll hop around, or you can look up here. You don't need your calculator to do this. Slope, you do change in y over change in x. Look up some algebra 1 problems, and you're writing an equation. That's the first part here. The second part is the new part for most of you, and that's using your calculator. And 2 things have to happen. One, you have to go to catalog and turn your diagnostics on. So catalog, and you have to make sure that your diagnostics are turned on. You just find it. And when you get there, you turn it on. My diagnostics are on, so I'm going to make sure. Yep. Okay, so then to calculate the line of regression, you go stat, calc, and then you pick Lin regression, not natural log regression. Okay, so I'm going to go stat, calculate, Lin regression, AX plus B. Some of you have 2 options. Pick the AX plus B, that slope-intercept form. Okay, here's the key. Whatever your X values are in list 1, Y values list 2, no frequency list. There's no frequency list. Okay, so I calculated from my little list, and I get this equation. Y equals 1.22 X minus 5.40. That's my line. Okay, and then the R value is 0.966. That's my correlation coefficient. All right, so that takes care of the front side. I'm going to quickly go through some of the questions here, talk about a couple things, and then you can open the PowerPoint and play it, download it and play it to answer some of these other questions. Correlation coefficient, what is it? It's R. Look at it in chapter 11A. And then the second paper, the paper you're going to pick up today in class, has a chart for how to decide what is strong correlation. And with correlation, we want to say it's either strong, moderate, or weak, and then positive or negative. Those are your choices when you describe correlation. Positive's getting bigger, negative's getting smaller. We're talking about the slope. Strong, this is how close the dots are together. If you guessed everything correctly, the equation of the line would be y equals x, because all the x's and y's would be equal. I don't know what this answer is for you. I can't answer that for you. You can find the percent. There were 20 ages, and you can take and figure out your own percents. Okay, the big news here, interpolate and extrapolate. You don't have to know these to answer this question. Okay, if I take my equation, y equals 1.22x minus 5.4. X was, my X list was my estimate, and Y was the actual. So if you guess that a person's age, that's an estimate. So basically, this is a plug-in 26 for X, and what does Y equal? And that's the same for you. You won't get the same answer, but it's the same X. And then the second one is if a person's actual age was 37. So that's Y equals 37. Find X. And this one says estimated age. So that's X equals 80. Plug it in. Now, you notice these both said interpolate and this says extrapolate. That is because they are different. And we talked about in the other classes, what's the difference between these numbers and this 80? Well, interpolate, inter means between. So if that's my range of values, Interpolate is anything that is between the poles of my values, and extrapolate means you are looking outside. So inside the data, we found this line, and then we use the line to predict outside of the data. The extrapolation is dangerous. It's not as reliable. Okay, so then you plug your own age in, and you just answer these questions. And the last question, the average difference of the ages, and it says add a column to your chart. I don't care. You can just make a nice little line right here and find the differences. Okay, so the second thing you're going to do today is you're going to estimate the R value. You're going to calculate the R value on this paper. So you pick up this paper and mark this up, because you're going to need this for when you do your IB project. Make sure you circle that formula or highlight it, something. So R you can find on your calculator, or R you can do by hand. We don't want to do this by hand very often, but I want you to see how to do it, so when you do your project, you know what to do. So there's two things you need to find. You need to find the average X and the average Y. So I'm going to find the average X, that's 6, and the average Y is 6. You can use a calculator if you need to, but come on, really. So then we just fill in the table and follow the properties going across here. So 2 minus 6, 4 minus 6, 7 minus 6, 11 minus 6. And then Y averages 6, so 10 minus 6, 7 minus 6, 5 minus 6, 2 minus 6. Okay, so now you have the differences between the average and the values. Then the next column is to multiply these two together. Multiply, multiply. Why don't you pause it and see if you can figure out the last column. Pause. So now this column is squaring this. So 16, 4, 1, 25. Squaring that column. And then squaring that column. 16, 1, 1, 16. Okay, and then to do the actual calculation, we need some sums here. So this means sum. So I'm going to add up this, and I'm going to add up this, and I'm going to add up this, and I'm just going to plug them in that formula. That formula is right there. So I get the sum of that, so negative 39, over the square root of 46. I guess I have to put it times like this because it confused the people. Thought it was the dot meant multiply. 46 times 34. So you should get the same R value that you get if you put in list 1 and list 2. So I'm going to do that. Just try to see if I can do this before I run out of time on this video. So I'm going to put in 2, 4, 7, 11. I'm putting it in list 3 and list 4 because I don't want to lose my other list. So stat, calc, linear regression, and I got to change this to list 3, list 4. So I get negative 0.986. And I want to see if that's the same as if I'm doing this with the calculator, using the long way. Negative 0.986. So they are, that either way works. Obviously, we want to use technology unless we have to explain it the other way. Okay. So for your assignment, this is the chart you can use here. For your assignment, I gave you a place to fill in some of these definitions, kind of be more organized. You can use my definition that I gave. You can watch it again if you want.